Thank you, everyone, and you see me again. so this is one of the final session of the day. So the topic for this session is, again, talking about the broader concept of smart mobility, and we are going to have a full session with presentations, panels, and then we will have still one session after this one where we're going to close the day of smart mobility. So as you can see, the title is Waving the Mobility of the Future, so better together. But let me introduce you to the format. So we will start with first having a presentation from one of our sponsors. So it's going to be Jess Smith from AALTO, that will give us a brief overview of what they're doing and why they are relevant for the smart mobility. Then we're going to go to a panel, and you can see we have quite a full panel with expertise from different industry. And then we're going to close with a brief presentation. So we will have a presentation from the honor, also talk about a little bit more on the future, looking at going from 5G to 6G, and then introducing the final session we will have later on. So I don't want to waste any more time, so let's please introduce and let's welcome Jeff Smith, which is the head of mobile connectivity EU and APAC for AALTO. Jeff, for you.
Thank you, Barbara. Thank you so much. Good afternoon, everybody. My name is Jeff Smith, as you can see, heading up mobility at AALTO HAPS. I'm not sure how many of you understand or have you heard of HAPS. Can you raise your hand if you've heard of HAPS? Only a few. So I know how to pitch the presentation to you. Zephyr is a stratospheric, unmanned, solar-powered drone. It flies 20 kilometers above the Earth, up to 6 months at a time, and it can be a platform that enables connectivity or Earth observation and sensing. But before I go any further, I want to show you a little clip of some video to get your brains thinking a little bit further of what could this mean to me.
Wingspan 25 meters and weighing only 75 kilos. 100% solar electric, operating above 60,000 feet. A record-breaking 64 days in the stratosphere, non-stop. With our ambitions set on much more, the AALTO Zephyr high-altitude platform station. Think the unthinkable, and it's now achievable. Zephyr can act as a telecommunications tower in the sky. Astonishingly high coverage. Ultra-low latency. Seamless infrastructure for MNOs to connect people from the stratosphere. Extending the radio access network with our coverage as a service approach. Helping to bridge the digital divide, to connect the unconnected and the underserved in ways not possible before, enabling new capabilities for governments to use stratospheric connectivity and Earth observation to monitor borders, enforce law and order, and manage disasters. Game-changing, payload-agnostic technology to help us build a better stratospheric future. The future is stratospheric.
So this is the Zephyr, as you've heard, a 25-meter wingspan, only weighing 5 kilograms less than myself, unfortunately. It's a carbon fiber composite with extremely unique and innovative solutions, and we have been developing this over a number of years. This footage here shows you how easy it is to launch. We don't need runways. We don't need airports. 75 kilograms is very, very simple to get in the air. Once we launch this, it takes 8 to 9 hours to circle up to the stratosphere, which we can then go in any direction about 1,000 nautical miles per day. Now, being solar powered with battery technology, there's a couple of limitations, which is year-round coverage may or may not be able to be done outside of 40 or 45 degrees north of the latitude or south of the equator. But what it does mean is we have a very, very carbon positive platform. For those of you trying to reach your sustainable development goals and carbon neutral connectivity, the Zephyr is a fantastic alternative to be embraced. We can operate year-round today, plus or minus 30 degrees of the equator, and within the next couple of years, up to 40 degrees. But that's not to say we can't do missions during summer months. So we could fly over the North Pole, for example, during summer months, because it's all about the availability of solar. How do we fit into the non-terrestrial network layers? Well, the HAPS is the latest and newest layer that sits within the GEO, LEO, and terrestrial space. The benefits that we believe that HAPS can bring is ultra-low latency when compared to satellite, and that has a really meaningful impact in the platform mobility space. If you're talking about connected vehicles making life-changing decisions, whether they're eVTOLs, whether they're drones doing delivery, you cannot have tens and tens and tens of milliseconds of delay. You have to be making those decisions on the go. The other thing with HAPS is it's extremely cost-effective to reach new places and expand your coverage and reach. You could create new corridors for connectivity, for drone delivery services, for example. Mobile connectivity is the main reason that we're here at the show, MWC obviously, but we have other capabilities. We have very high resolution camera on board that we can use for Earth observation and sensing. We also have other government and civil customers who may want to bring their own payload to us, and we integrate that onto the platform. So you can imagine the possibilities and use cases that we can apply are many. How does it work as a tower in the sky? You saw the snippet in the video. Basically, we are acting as an infrastructure offer. So when we come and speak to you as a telecoms operator or a mobile network operator, what are the things that are important to you? The first one is control of your end customer experience, control of the billing and the relationship with your customer, control of your network and the quality, whether that's for a disaster recovery scenario or whether that's for permanent or temporary coverage. But no, so data sovereignty, if you're talking about LEO and GEO type services, often that data is leaving your country's national borders for processing and gateway connectivity. We can remain static or above the area where the services are required. So the use cases that we have are many, and one of them, as I mentioned, is Earth observation. So if you're used to going to Google Maps, the resolution of the imagery you see there is about 1.5 meters. Our camera technology gives 18 centimeter resolution. And how is that impressive? Well, it's different because this platform can remain persistent over an area. It can track, it can follow, it can monitor. Unlike satellites, which obviously have to pass maybe once, twice, 3 times a day, depending on the orbit that they're in. So it has many, many applications. The next generation will also have infrared capability as well, which means for disaster recovery, disaster management, fires, floods, etc., you can not only have connectivity provided, but you can also have eyes on the situation. AALTO is a part of the Airbus group, and we have been doing this for a number of years now. We hold many records, a couple of which are the longest ever stratospheric flight of 64 days. Our ambition in the next few years is to reach 200 days non-stop flight, which is basically a 6-month service delivery capability. That's when it becomes very meaningful for your permanent coverage requirements. We have an R&D facility based in Farnborough in the UK. So if any of you are very interested in this type of technology, I'd love to speak with you afterwards and we can set something up for you to maybe come and have a visit. We have over 4,000 hours now of stratospheric flight below us, and the multiple records also include the highest altitude reached by this type of aircraft. We have a stand here today, just over behind us here at 4B25. We have a 1/3 scale model of our aircraft. We have our antenna on display, which show you how we do beam forming to give you, the network operator, the control you require. The other thing I wanted to really share is that because we're an infrastructure player, we don't have aspirations to become a mobile network operator or even a virtual network operator. So we work with you as a mobile network service provider. We bring the aircraft, which is like a tower. We bring the power, which is the battery and solar. We bring the active antenna. We bring the backhaul, which is the link down to your nearest edge gateway. And then you, as the mobile operator, will keep your eNode B or gNode B on the ground. Your base station stays on the ground, and we relay that signal through the aircraft. The way that this delivers the service means that it is a completely seamless offering to your customer base. Your network management teams control that offering. You control the way that you price and position it with your end customers. And we act as an infrastructure, flying tower. So it's a very, very simple, non-invasive approach. We have signed many agreements already. We're looking to sign even more here this week. And I would encourage you, if you want to know more, please come and see us. We have a full team just over behind here who's more than willing to share more of the capability, the time phrase for entry into service, and the obstacles that we have overcome and are still working through to bring this to reality. So I think that's everything from me. I'll now hand back over to you, Barbara. Thank you very much.
Thank you for that. So I will ask you actually if you can go and we change your microphone. So I give this one also back. So in the meantime, so we are going to go to introduce our panelists. So I will start from the end, coming all to here, so we give time to change the microphone. So if I can ask Damien Kiesely to come on the stage, which is head of EMEA Skyports infrastructures. If you don't know Skyports, you will learn how they fit in the topic. So if you can sit on that side, so it's easier. Then I'm going to ask Laurence Montanari, which is working for Dassault Systèmes and is the vice president for the automotive sector. So thank you very much. Yes, perfect. The next one coming on stage is Khalid Moussad, which is working for eEnt and is the CTIO. So please, thank you for sitting there. While we are also waiting then to have Jeff joining us. So Jeff is already prepared. So thank you very much, Jeff. Thanks for doing that. So we all fixed.
All good.
So now I wanna actually start on a conversation and go in a little bit more in the detail, or why we are here, what is that we are going to discuss. And I'm going to start maybe first from the only mobile operator in the panel to give a little bit of perspective. First of all, if you can introduce yourself, give it a bit of an idea who you are and where you work with. But also tell us a little bit on, how you see the telcos playing a role in smart mobility in general. What is your vision, and also from your company, basically?
Thank you very much, Barbara. After the magnificent presentation of Jeff, I was only relieved when you said you were not intending to go as a mobile network operator. So we might then pick up some talks about collaboration. But seriously, in smart mobility world, we believe mobile network operators or telco operators can position themselves in the heart of providing efficient, reliable, uninterrupted infrastructure or connectivity that any intelligent transport system will need to operate, be it in an IoT environment, or be it in a V2X environment, or be it even between road transport, sometimes maritime transport, even air transport. We will always be the infrastructure provider who provides those kind of connectivity. And now the advancement of the infrastructure makes it more even reliable and more suitable to connect massive IoT connectivity in a very reliable and real time, which is very crucial here, latency. So I believe that's in a nutshell how we can provide value addition to this society.
Thank you very much for that. So then I'm going to move a little bit in a completely different area. Let's say, Laurence, you are from Dassault Systèmes. Maybe if you can introduce who you are, where you work with, and what is the company doing in the area of smart mobility. I know it's a huge company, so let's focus on some area that you are primarily interested in.
Yes, I will. Hello, everyone. So I'm Laurence, and I'm working for the automotive sector. So for a long time, I've been working for more than 28 years before joining Dassault Systèmes. And in Dassault Systèmes, we think that we can improve the real world by designing, modeling, and simulating the world before moving to the real life. So, of course, we design and model cars, but not only, we serve 11 industries globally, connecting things with ecosystems, different ecosystems.
Thank you for that. And I know that you also not just work on the automotive, but you also have a lot of areas like in aerospace.
Yes.
So it's quite a huge company. Now I'm coming to you, Damien. So can you introduce yourself and also explain what Skyports infrastructure is and what you do?
Sounds good. I hope you can hear me okay. So Skyports Infrastructure is an infrastructure company focused on the electric aviation space. So we develop and operate infrastructure called vertiports. It's a new type of small airports specifically designed to handle electric aircraft, whether that's cargo drones, so unmanned aircraft, or passenger eVTOLs, electric vertical takeoff and landing aircraft, which are being introduced in the market in the next coming years. We handle both the physical infrastructure, sort of architecture engineering as you know it when you have to build any airport, but also the digital layer, which ensures communication with the aircraft and the operator and the infrastructure layer to make sure that as levels of automation increase, especially in the aviation space, we have infrastructure that is ready to enable more automated and potentially one day autonomous operations up in the air. We're mainly focused on urban areas, so connecting different parts of cities, but also slightly longer flights of about 100 to 150 kilometers as the technology evolves, obviously, as there are certain limitations that electric aviation industry has in terms of battery capacity. But as that improves over the coming years, the range will also extend and we'll be able to connect a lot more remote and distant locations together.
Thank you very much for that. Then I'm coming back to you, Jeff. So you give us a presentation, you know, what AALTO is, what you're doing. Can you maybe go a little bit more in detail to say what we're looking as a timeline? Sure. When do you expect actually to be live or commercially? And also what are maybe the obstacles or challenges that you face to go live?
Yeah, sure. So as you saw, we've already had over 4,000 hours of flying over the past multiple years. Right now, we're looking at an entry into service target of the end of 25 into 26. The main reasons behind that are creating something of this scale on a global basis requires launch and landing locations, and we're just establishing our first one in Kenya as I speak. And we'll have another 2 or 3 that we add, which gives us that year-round access to the stratosphere. We're also looking at the design for manufacture process to basically build at scale. Mm-hmm. But the most important one, and probably the biggest obstacle right now, is just certification. Mm. It's not really an obstacle, it's just a process we have to go through, and it takes time. And so that's the first one we have to go through. I'm very pleased to say that 2 of the previous obstacles or challenges have now been dealt with, and that was with the radio access spectrum. So in WRC23 in Dubai last year, obviously the ITU approved the recommended HIBS or HAPS spectrum allocation for the service link, which means a fantastic market opportunity is realized for all HAPS operators, including AALTO. It means that people can now look at the regulations and apply the right spectrum. WRC19 already overcame the feeder link and backhaul, so now it's down to the regulators and the mobile operators who wants to be the first to deploy the first live commercial services. Okay, thank you for that. You talk about certification actually being one of the obstacles, maybe for the audience, because when we talk about certification in our industry or in the automotive industry, time is completely different. The timeline
is different. When you talk about certification for your vehicle, how long are we talking about? What is that it takes?
So we're aiming to have that certified in the next year and a half. That's the time frame we're working towards. Obviously, you know, when you work with the CAA and FAA and others, time frames do alter.
Loose, yep.
Yeah, and the unique thing about the Zephyr is obviously it's not a plane in the conventional sense. It's not a drone in the conventional sense. So when you speak to a regulator, there's no box to fit it into.
Yeah.
So obviously the great experience that we have with our Airbus parent is they know how to certify, build, and manufacture aircraft. So we feel we're in a very strong position to write new rules, work with the regulators to make this a reality.
Make this rule. Okay, thank you for that. So we're talking about connectivities, you know, from the apps perspective. But maybe I come to you, Khalid. So do you see hubs or all these satellites, different constellation of satellite, providing then, you know, an ubiquitous connectivity, seamless connectivity? Is it something that you see it coming closer? Or do you see it from perspective of a mobile operator? What is your view?
I think from an operator point of view, we're seeing a lot of evolving technologies around that. Certainly HAPS is one of them. LEO is a strong also contender in that space. What I don't see is that this is going to be successful if we don't come together and create a platform where everyone, and this is very crucial, everyone understands the strengths of each technology. I'll give you an example. Imagine a connectivity that requires 2 milliseconds of response time in a very reliable manner to take a decision that after 2 milliseconds it's going to be too late. Would you want to entrust that to a satellite? The answer might be no, but some people will argue. But if I have a connectivity in the middle of the sea for a ship that carries different, you know, kind of applications, why not to augment my solutions in a win-win, probably win-win-win-win-win, with so many wins on the table, platform that brings and augment each other's connectivities portfolio. And I think Jeff touched brilliantly on that in his presentation. We are not here to compete, but to augment the whole portfolio. And this is the right way to tackle things. So the answer might be yes and no, depends on how are we going to tackle this in a collaborative way.
Understood. And we are at the beginning, I guess. I mean, hubs and satellite have been there for a long time, but we see these changes quite new and coming along. So there's a lot of work that we need to do together.
Yeah.
Maybe I'm going to stay with you, Khalid, and try to figure it out from your perspective. What are the things that you see where they are transforming the mobility? From the telco, what do you see from your side that are going to shift mobility in a few years?
I think we've been connecting mobile users for the past 50 years, right?
Yeah.
Or maybe even more than that. But I think that the advancement that is coming in the next few years is mostly related to things and connecting of things, which is very much in line with the smart mobility world. We can talk about the 5G advancement or the 5G advance, which is going to allow massive connection to IoT with a much lower latency and a higher reliability. But I think the real advancement might come with the 6G also, in the promised use case of 3D positioning. You can imagine how is that going to augment those IoT sensors or even replace them at a certain point of time. Edge computing is a major thing that could also play a good role in that. But going back to the point where we collaborate, 3GPP standards will evolve to touch on the collaboration between terrestrial and non-terrestrial network in a solid standard, because this is also something that we need. Yeah. We all need to follow one standard in order for us to plug in a hub when I need to cover an island in the middle of nowhere, for example, or I need to cover an event in an uncovered area. in a seamless way because they're following the same standards that we are following, and they're going to feed into our trouble ticketing system and the performance management system. The standards is a crucial thing to be the foundational layer for the collaboration.
For scale and simplicity, yeah,
Absolutely.
I understand it. Laurence, I'm coming to you. Obviously, you've been in the automotive world for quite some time. So what is that you see now that is going to change on mobility in the coming years?
I think we can dream. We can have a dream on the standard.
Oh, yeah, we
it's
can.
not for today. Sorry. Because there will be a standard for drones or for AALTO, but a standard for the communication. Cars, there are other standards. So the question is how to combine all these objects together in the same system. That is the key question, because the efficiency of all of that, and of course, including eVTOLs, will come from how to combine in a territory all these objects together with their own standards. And that is the key point of the industry and the mobility is facing today. Because the question is how to do that. There are public and private sectors. There are different languages, different timelines. So that the complex things is really to do that. So that's why there are some examples all over the world. We can see few examples all over the world addressing mobility for territories. I have an example in mind with a telco company. We partner with NTT in Japan to analyze the flow of people in case of disasters.
Yeah.
And we were able to work with Kyoto in order to simulate that. So data are coming from Kyoto, and we are able to simulate what does it mean in case of disasters. In the morning, in the middle of the day, in the afternoon, it's completely different for the evacuation plan. So that's why it's time to connect all these different ecosystems together. And in this complex situation, modeling and simulation, it's where it's helpful. If you are only modeling and simulating one object, you can stay with one technology, you don't need to connect. But in such cases, you need to connect different ecosystems. There is another example with the human first vision in the GSMA booth, the concept car.
Oh, no, thank you for that. And as you mentioned, so we try to basically model as much as possible that is closest to the real life. And when you say model, it's not, for example, on a car, but it could be, as we said, we've seen before in the drones, is external environment, which is keep changing. So the challenge, I guess, is that it's not a static environment. It's a very dynamic environment. So, and it's very different from places to places.
Yes.
Then maybe I come to you, Damien, because you are from the infrastructure of, let's say, a vertiport.
Yep.
How do you see it, also the changes from your perspective, but also what type of infrastructure? When we talk about infrastructure for you, what do you need? What is it that
Sure.
you mind? And what is the role of connectivity for you?
Sure. So I think if we sort of look at the electric aviation space, drones, eVTOLs, the common denominator that will allow the scale of this industry is low-level airspace connectivity. It's typically something that hasn't been used, required, but it is absolutely essential for electric aviation to scale. And whether we're talking about unmanned aircraft, which carry cargo payload, or whether we talk about large aircraft without a pilot that carry people. It's sort of the same type of approach. Currently, when we operate or when our partners operate drones, so unmanned aircraft, they typically use a combination of radio, LTE, and SATCOM as a redundancy in case there's a loss of signal. But all of those flights are generally pre-planned. So there's certain logic where the drone can make decisions on its own, but it's not in response to, typically it's not in response to sort of the tactical orientation within the airspace. It's told that if certain conditions happen, they will sort of do A, B, and C. But they're not able to compute and act autonomously. And for that to be possible, we'll need reliable, fast, low-level airspace connectivity, which currently doesn't exist. That goes hand in hand with regulation. The regulators will not allow for drones to be scaled until that connectivity link can be proved, so that can ensure safe operations of the drones. That's even more true for aviation, manned aviation, where you carry people. So if we're talking about autonomous air taxis, that burden is a lot higher in terms of allowing autonomous aircraft to fly around, especially congested environments like cities. So what we're going to see is a sort of gradual increase, sort of crawl, walk, run approach, where drones might be scaled in certain areas for certain use cases where connectivity is provided. There's a number of projects around the world by various telecommunications companies, including in Dubai, UK, where they're creating corridors with low latency infrastructure to allow for this kind of operation to happen. When we look at the passenger carrying aircraft, these will launch with a pilot on board. So it'll be no different than a helicopter. Going to have a radio connection, communications, two-way communications between the pilot and the air traffic control and the infrastructure. But it's going to take some time before we're going to see autonomous aircraft without a pilot operating. First, that's probably most important for the connectivity layer. We're going to see pilots operating many aircraft from the ground, which means the aircraft has to be reachable at all times. And maybe over time we're going to see decision-making on board of the aircraft. But again, that we'll get into sensor technology and detect and avoid, which again is few years away from being allowed by regulation. So, as I said, the sort of low-level airspace unlock, whether that's through ground infrastructure or infrastructure like Zephyr is putting in place, that's key until we see scale of the electric aviation industry really kick off.
Okay, no, thank you very much. And yeah, you touched quite a few points, and I'm trying to. So we talked about autonomy, and we also had during the day the talk about the different levels. So when we talk about autonomy, to go to fully autonomous, there are different layers and different steps where we need to take. In the automotive, indeed, we have different small steps to get to the final, let's say, fully autonomous. Maybe I come to you, Jeff, because you are operating something which doesn't have a pilot, at least on board. So how you consider your, let's say, aircraft is semi-fully autonomous? Where are you in this autonomy journey?
I mean, Damien, you hit the nail on the head. It's all about regulatory rules and allowances. At the current standpoint, we have to have a pilot flying each aircraft, albeit that pilot might be in the UK and the plane might be flying in Africa. Mm-hmm. So we are definitely pushing the boundaries of remote connectivity and control. That said, we obviously have to have fail-safe capabilities in the platform. So it has pre-mapped waypoint capability already. So if we did lose connectivity, we are in a safe and secure position that we know what it's going to behave like and what it's going to do. But, I'm very, very similar to you, Damien, in the view is that it's going to come with time and it's going to come with proof of ability. And then the regulators will start to hopefully see what that may open up for the market capability. We're lucky we don't have the ability to carry any people. I wouldn't want to be at 70,000 feet myself with no oxygen, but, we don't have to worry so much about that. Yep. It's more about the risk to life. If one of these does come down, what does that mean? Yep. So, yeah, for me, it's working with the regulators. The more and more hours that we get and the more proof points we have, then the more open they will be to the way that they're going to allow us to operate these.
Understood. So you're also taking a stepwise approach to do one step at a time, see where we are getting. Still staying on the autonomy journey, how do you see, Laurence, the modeling, that you talk about modeling, how modeling is helping us on that journey for autonomy?
So today it's used in the ADAS simulation. So how to make a car more autonomous with all the features embarked in the car. So, and there are a lot of capabilities to design the system, how it works, to simulate it many times with different scenes and different scenarios. And it's the way to get the approval from the authorities, because you need to go to the certification, you need to explain how it was validated.
Yeah.
But usually a lot of validation are virtual, because you are able to explain how your sensors are used, how it works in the system, and to simulate the system. So that's why for one object such as the eVTOL or the plane, it's done for the car also. And it's the way that the car makers and the airplanes are validated today. And we are able also to say, okay, this object is in a different environment. Now I'm able to validate this object in a new environment, depending on the connectivity, for example, because when you have no connectivity at all, you need to understand how the object will move or not. So that's why there is one level of the object itself, and then there is another level of the system engineering or inter-system depending on the environment. And we use system engineering for that.
Wow, that's so it's quite a complex.
Yes.
One thing that maybe I can ask is, in different steps like automotive, HAPS, or the new eVTOL area, we are in need of data. But do we have already all the data to help us to take the decision, or we are still in a phase of collecting data first? Or maybe it's a different, in different area we are in different steps. So how far you think we are maybe?
So I think obviously from our perspective, every flight, every hour, every minute, we're collecting data.
Yeah,
and we're learning from that data, we're processing it, we're analyzing it, we look for improvements every time. So, and I guess I can mention the HAPS Alliance. Obviously, as part of the HAPS Alliance, all of our fellow competitors are doing the same.
Yeah.
And I think the more platforms that are operating in the stratosphere, the more intelligence and the more data we all gather collectively for the greater good. Because that is one of the challenges in the stratosphere for us is, if you think about history, the only thing that's operated there is Concorde, US U-2 spy planes, and the odd spy balloon, right? So there's not many people that operate in that space. Civil aviation has millions of hours of data and history. We are at the forefront of delivering that data now.
Understood. So I don't know if, Damien, you have any inputs on the autonomy and the data?
Yeah, I mean, similarly, we're earning the confidence of regulators. So in the drone space, the unmanned space, it's every time you come up with a concept of operations, you're allowed to typically test it in a very limited, controlled environment. And if you prove to the regulator that you can do it safely, and all of the potential sort of situations that may come up, you can handle safely through your operating manual, then they allow you to sort of expand the flight envelope and do slightly more riskier or advanced operations. If we look at where the drone industry was 3-4 years ago, basically no one was allowed to fly beyond visual line of sight. So the pilot was always required to see the aircraft and then be able to land it safely at any one time. Today it is quite common to see BVLOS operations around the world, but again in fairly constrained environments. So I'm sure in the next couple of years we're going to see a lot more integrated drone operations all around the world, including in and around airports. When we look at the eVTOL space, we're using a lot of the existing regulations from the helicopter industry. So the main innovation is, I don't say innovation, but the main difference from helicopters is that the aircraft is battery powered. So there's a whole type certification challenge around that, and the aircraft OEMs that are building these aircraft are collecting data every single day as they fly and prove that the aircraft is safe and matches the required safety standards. What will be interesting is once we launch piloted operations within the next 2 years, actually in Dubai, how can we use that data from initial operations to lay out the journey to autonomy? And I would say no one has a good answer at the moment how that will look like. What I would say is what's absolutely critical for any of us is the support of a government that is willing to take on some of the challenges and risks, do it in a safe but sort of managed way to allow these technologies to be proven, to collect the data, to be able to then design relevant regulations. And I think there's not that many around the world that have the courage and resource to be able to allow this. I think Dubai and UAE is one of those countries that I believe will soon have these type of services integrated into daily life. And it'll be a great way to share that data with other countries which maybe don't have enough resources or courage to take that step and help our industries to develop.
All right, so we're getting closer to the time. So maybe I want to just very quickly, each of you ask what you would see as, let's say, a final remark on the future of mobility. How do you see it?
It's a multi-layered approach that will provide loads of options for people to decide, but we need to stitch it together as a single ecosystem to be successful.
Thank you for that. That's very nice. Laurence?
So for me, it's a multimodal mobility. Yes, optimized territories per territories, because Barcelona is completely different if I compare with Paris or London.
Nice.
I couldn't agree more with Jeff. I think it's a collaboration that needs to take place where everyone will share. Look at the example, for example, in Dubai, there is an example of the autonomous cars. We have augmented our infrastructure only for the purpose of making it suitable for that autonomous cars to be more reliable and more trustworthy for the regulator of that segment to be. So in a way, our bread and butter is connecting people, not only people, but 5G promised us also to connect industries, and this is what we do.
Thank you very much. And just the final word for you.
I would say mobility and the mobile industry are converging. Historically, when you thought of mobile industry in transport, it was about Wi-Fi on trains. I would say the paradigms is shifting in such a way that it's effectively becoming this with wheels, but it's extremely connected and digital infrastructure is an essential part for any type of mobility going forward.
Okay, now we are done with our time. Thank you very much for this one. So if you can just give an applause to our presenter.
Thank you.
So we go to the final round. So I ask you if you please can go back and sit. We will have then the last presentation of the day. So as I mentioned, the final presentation will introduce it to the 6Gs, basically. So the journey from 5G to 6Gs. And we're going to have Samuel Deng, which is the Chief Technology Officer of Honor Device. So please, if you could just give an applause to Samuel, can come now to the stage. Thank you very much for having Samuel. And thank you for also being one of the sponsors of the Smart Mobility.
Thank you. Thank you very much.
So over
Thank you
to
for
you.
hosting
Thank
me.
you, please.
Okay.
Oh, yeah, sorry.
Okay. Hello, everyone. Welcome to MWC. My name is Samuel Deng, and the owner CTO. I'm sure you're very intrigued together with me by the previous speakers, the discussion of smart transportation and digital cities. In the presentation, I will try to explore a human-centric, intelligent world shaped by 6G and AI. I know some of you, just like me, from faraway place, and may have experienced the difficulties dealing with the flight, hotels, and agendas. Well, the good news is that our smart devices are getting smarter, and in the soon future, I think we'll attend MWC in a more convenient way. So my slide will have three parts. First part, I will try to use a simple cognitive model to understand the ICT industry development. Second, then we will review terminals' role in the development. And lastly, let's explore the 6G era and the 6G terminals. The ICT industry is a whirlwind of constant change impacting every aspect of your life. Its vastness and complexity can be overwhelming. But how can we gain a simple understanding of its decade-long evolution? Some say the ICT industry is like the rebuilding signal tower and then tearing them down and then building new ones again. I'm sure this is relatable for many of you, as it highlights the continuous progress and the distribution in our field. Looking at the bigger picture, a key concept in ICT is information flow, the movement of information that drives everything. From 2G to 5G, we have witnessed a dramatic increase in information flow efficiency. We went from text-based information for near reality experienced in decades. So our smartphones have become more than just devices. They are practically extension for ourselves. Imagine going a day without them. Maybe the feeling is the disconnection, frustration, and even anxiety. In this information flow, smartphones play a central role in supporting and driving new technologies. Take a video call, for example. The camera and the microphone to capture audio and video information, then the smartphone processes, stores, transmits it. Finally, the sound and the picture presented through the screen and speaker, that's what a video call comes out. We just established that the terminals play a vital role in supporting the entire information role. But how have they evolved to meet this growing demand? Let's embark on a quick journey through terminals' history. Terminals have evolved from the feature phone in 2G and to smartphone in 3G, from advanced smartphone in 4G to the innovation device like our honest foldable phone. But 5G, when 5G comes, they also allow the smartphone to simply collaborate with the PC, smartwatch, tablet, TV, and other devices. The transformation from the 2G to 5G terminals has continually improved the information flow. With the rapid advances in the 6G AI, we are on the cusp of the intelligent connectivity of everything. Imagine a world where the physical and the digital seamlessly blend, opening doors to unimagined possibilities. Every action you take in the physical world will be meticulously recorded and mapped to the digital world. But with a crucial twist, you are in control. Of course, very security control. Your terminal will learn your intentions and habits and seamlessly to give the information flows across different devices as a very trustable assistant. Terminals will transcend their current role. They will become essential bridge between the physical and the digital world, unlocking the gateway to the exciting new world. At Honor, we believe that creating a new intelligent world for everyone is not just a logo, a slogan, but also our mission. So imagine the information flow in a 6G future fueled by the advanced terminal optimization efficiency. Let's take the 3D holographic video calls. For example, multiple terminals smartly collaborate to capture 3D information, even the sensors, so according to the user intention. They will use the less information, less sources to translate and enhance the 3D information intelligently, transmit them through 6G network, and ultimately be presented back to you. Instilling 3D audio and video, of course, you can have the good performance of the 3D holographic, but also can even experience multiple dimensions information like the smell and the taste. As we move closer to the 3G area, Honor is working together with the GSMA as they delve into 9 compelling scenarios that showcase how 6G will impact users' daily lives and experiences. Our motto is value for users, technology for good, from immersive entertainment systems with multi-sensory experiences to virtual classroom tailored to individual learning styles and much more. Let's imagine a remote healthcare consultation. Of course, the first thing, when some user at home talks to the intelligent assistant, like the Honor's UU, I'm not so comfortable. Secondly, the UU will recognize the user's extension. Not so comfortable, maybe the meaning is that I want to see a doctor. You will connect to the AI doctor, maybe the digital or the physical, and very soon. And thirdly, you will smartly switch to the 3D holographic screen for diagnosis. During the diagnosis, the UU smartly switches to the user's smartwatch to collect the heart rate, blood pressure, temperature, and the other information, while your phone displays your personalized profile. And next, AI doctor uses these general and personalized AI models to carry out a comprehensive diagnosis, ultimately give a diagnosis report. For example, users need to correct the sitting posture. Maybe you don't feel well. And then, at the last, you will record the diagnosis report, intelligently recognize that the user is in working state, and remind the user to correct the sitting posture by watch or other devices. So that's all. That's the circle life, or the closed circle, that how the AI will help and how the 6G will help want people to keep their healthy. According to these 9 scenarios, Honor and the GSMA have summarized the 4 major capabilities that distinguish 6G from 5G. They are all-around communications, real or all-around communications, native AI, real virtual fusion and multi-sensory information presentation, and expansion and calibration. I think 6G promises another revolutionary leap, further shaping human society and life. Let's work together to make it clear. In collaboration with GSMA, Honor is proud to release the 6G Terminal Vision White Paper. This document outlines the future of the connectivity through the 6G terminals. We are grateful to our collaborators like the China Unicom, China Mobile, China Telecom, Du, Telstra, and Inmarsat for their contributions to this project. And if you want to download the white paper, please scan the QR code. I'll download from the Honor website. And thank you very much.